Greetings everyone, today we will learn 4th chapter kinematics. This will be the second lecture of this series. 4th chapter kinematics, lecture number 2nd part. So in this lecture students we will discuss graphs. So let's see. Yes. Graphs of one dimensional motion. So let us suppose one graph, this is S and this is T. T is represented on x-axis and displacement on the y-axis generally. So let me write meter. So slope of this graph, I am drawing a straight line here student. This is theta angle being given and this is the displacement S being created. So what should I write? Slope. So slope is tan theta and tan theta value is what? Y2 minus y1, x2 minus x1. Then this gives S2 minus S1, T2 minus T1. This happens to be what? Del V. Del S upon del T and this happens to be del V. Yes. So del S upon del T and this is V. Del V. Velocity. So this is slope of the graph. So you would ask that this is displacement. No student, this is not displacement. This is suppose distance. So displacement is S2, S1. Okay, let me give an example of this. So the thing about here to be discussed is that this is the last lecture of theory part of kinematics. Yes. Example, this is 50 displacement meter, this is time in seconds. So this is 10 and this is Vs. Your graph, this is displacement happening and what should I write? Del V should be what? S2 value is what? First let me write down the formula. T2 minus T1, this should give us 50 minus 0, 10 minus 0 and this is Vs, 5 meter per second. 5 meter per second. Yes, we have understood your thing that you have taken this S1 as to be 0 and 50, this to be here 50 meter. Now the second part, interpretation of graph. If theta is such that it is smaller than 90 degree. It is smaller than 90 degree. So what should I write? Acute angle. Yes sir, we know this. Acute angle. Then slope happens to be positive. Slope happens to be positive value. Okay. Even the thing about this kinematics is that this will not have so many of numericals. as vector's head. If theta is what? Greater than 90 degree, obtuse angle. Obtuse angle, slope is negative. Okay, now this is what? First case, this is second case. Now let me draw the first case for you and the second case for you. This is S, displacement S T, and this is acute angle theta. Okay. So what should I write as student? So you would write S is positive value, here positive y-axis, and time is also positive. So velocity comes out to be positive value, sir, and acceleration happens to be positive. Since velocity is positive, okay. Acceleration happens to be positive value. Second part, second case. So you see, as theta happens to meet 90 degree, it is giving everything coming out to be positive for a straight line graph. Now the second case, obtuse angle. Second case is what? If theta happens to be greater than 90. So what graph should I draw? So this graph you should draw. This is theta here, this is time, and this is displacement S in meter 50, and this is 10 second. We are taking to be t in second. So what should I write? So displacement happens to be positive value and time happens to be a positive value. Velocity happens to be positive. Student? No, sir, negative. How come, sir? How come negative? See here, student. V is what? S2 minus S1. Right? T2 minus T1. Then what should I write? 0. This is S2 is what? 0, no? 0. And this is 50. So this comes out to be 0 and this is minus 10. Right? T2, T1. So T1 is what? So it is 10, sir. 10. So you see 10, this is 0. And this is minus 5 meter per second. Okay. So you see velocity coming out to be negative. Then acceleration happens to be negative since velocity is negative. So what we should say? That acceleration is decreasing as velocity is increasing for a straight line. So even in numbers sometimes I got misplaced. So this is the thing. So with physics and mathematics this happens, especially with teachers. They got so misplaced with numbers, where to put the numbers. Concept is something that you can deal with, but numbers actually sometimes get misplaced with within the lecture. Non-linear one-dimensional motion. So this was linear one-dimensional motion, students. Okay, non-linear one-dimensional motion. So what should I write? So anything you like. This is S and this is T. And this is concave upward. Oh sir, the speed. Even I sometimes get annoyed with my speed and everything. Concave upward. So what should I say? V is increasing, positive value, and acceleration is also positive value. How, sir? How? See, students, S is what? Positive displacement, and velocity happens to be positive since it is increasing with time. So both are increasing. This is a symbol I am giving to increasing. This is concave upward case. Now concave downward. So you would be very happy that kinematics actually has ended with this second part, with the theory. Concave downward. Concave downward. So this is the general case of concave downward. This is 4-second time. This is for 1 second it is increasing, and for 4 seconds it is for rest 3 seconds it is decreasing. So S happens to be meter, and this is what? Displacement 10. So this is concave downward, and this is S happens to be positive. How come, sir, positive? Because students, I have taken what? Positive y-axis. This whole displacement has happened on the positive y-axis. Though it is 0, whole value is 0, but the displacement is positive. T, positive value, but velocity is also positive. So what is negative, sir? Acceleration is negative. So you would say, sir, velocity, how come? Because you see, displacement is on the positive y-axis, so velocity comes out to be positive in general. So I have not taken this y2 minus y1 case in this case. I have just given you the general criteria of concave downward, not everything into the detail. So if you see this graph happening now, so what you will notice? That displacement is on the positive y-axis. So generally velocity will happens to be positive generally, and acceleration will come out to be negative because the concave is downward. So acceleration comes out to be negative, downward, and this is what? Positive. The next part, what does the next part say? So it is observation, no, student, that we will write now. Observation, see the observation. What should I write about observation? Observation. 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 First observation, V, A, same sign, speed increases. Right, student? So speed increases, and V, A, opposite sign. So in this case, see, velocity is positive, students, and acceleration is negative. So what should I write? Speed decreases. General speed is decreasing. Speed decreases. So the thing. The next part, even I can't discuss in this explanatory lectures much things, no? I can't discuss. There's so much as to discuss in the numerical section. S happens to be what, student? So S happens to be meter and this is time. So this is the case of negative displacement and what it is? Time in seconds. So what should I write? Concave upward. Again concave is happening upward. But this time displacement is what? Negative. So the displacement happens to be negative value. Even velocity happens to be negative. Okay, it's a general case I am discussing, student. Don't take it. So with the values here it comes out to be this and this. A happens to be yes, positive. How sir? How A is coming out to be positive? But a concave is upward, no matter if this velocity is negative and displacement is negative, acceleration comes out to be positive. So upward, so I would write upward, concave upward. So speed, what will happen? Speed would decrease of this. Why sir? Why would speed decrease? See, here velocity is negative, acceleration is positive. Speed decreases of this body. Wow sir, amazing. Now the second case. What is the second case, student? So you would reverse the case, no? Yes, student, I will reverse the case. But how would you reverse the case, sir? So the thing here happens to be, oh, the board. I would do this, student. This is this and this is yes. The reverse case of this. This is 0, this is S and this is minus S. So concave is what? Downward and displacement is S. So concave downward. Okay, student. So what should I write? S negative, velocity negative, acceleration happens to be positive. Acceleration happens to be negative. What I am writing? Acceleration happens to be negative value, na? So the speed will, what will happen? Speed increases. So how could acceleration coming out to be negative? See, student, displacement is negative, velocity is negative, and acceleration value is negative because velocity is into the negative y-axis. So generally I am discussing about the axis terms, generally, not the whole thing. So what should I write? Speed of this body increases. Okay, increases. So what is happening here? Velocity is supporting acceleration and acceleration is supporting velocity. So sometimes this happens, that you want the support structure to actually get your thing done, and the support structure is what? Velocity here. So the speed gets dependent in this way. If both the things take same sign, speed increases, and if both of them take opposite sign, then speed decreases. Now spatial graphs. This is one graph, this is second graph. So what are you doing this? T, let me explain this both graph to you. T. So this is impossible graphs. How so? This is how? Because see, at two positions, at one moment of time, body is at two positions, here at S2 and here at S1. So the thing. So this is impossible graph. VT graph now. Velocity time graph. Velocity time graph. What it does say? Acceleration is such that v2 minus v1 should be equal to what? v2 minus v1 upon t2 upon minus t1. This should be del v upon del t. Sir, you didn't write del a here? Yes, student, del a. So, how should I draw the graph of this, student? Graph of this should give us what? Acceleration, so acceleration. But the slope would give. Yes, very nice. Slope would give the acceleration. So I would draw v on y on this y-axis and this time on x-axis, and this is again acceleration. Okay. Slope gives acceleration of VT graph. Okay. Acceleration of VT, slope of VT graph. Oh sir, you are writing. So this should be what? Slope of VT graph should be acceleration. Now this is proper statement. Acceleration, and also area of VT graph should give us what? Displacement. Right, students? Yes sir, we have studied this in the 9th grade. Area of VT graph gives displacement. So the next part. You can actually do this area. You will see that this is triangle now, student. Area is what of triangle? Half base into height del v. So this is, yes, area of triangle. Next part, acceleration time graph. So you have already erased acceleration time graph. So what it will give us? Jerk, students, jerk. So slope of del A del T gives us jerk. Jerk, that is meter per centimeter? Second. Yes, second cube. Yes. So we were actually thinking what you are saying, centimeter. Area of AT graph should give us what? Change in velocity. Okay, student. Now the last part. Oh sir, the last part. What is the last part? We were waiting for the last part. No, so much. We thought that it would have something special. Yes, actually it has something special. Velocity displacement graph. Velocity displacement graph. Oh sir, we have heard about velocity time graph. What is this thing? Velocity displacement graph. See, student, slope of velocity displacement gives us velocity and displacement gives us acceleration upon velocity. So what should I write? Slope of velocity displacement is equal to what, student? Slope of acceleration and what? Velocity. Yes. Yes. Could you prove your point here, sir? You wrote something, and can you prove it? This thing you are saying. So let's see what I'm saying. I'm saying this thing. Acceleration is what? V dv by d. V dv. So where is v? A v dv upon ds. And can I write this thing as acceleration upon v dv by ds? So dv divided by ds. Yes, sir, we have understood your thing. So the same thing. Also A is what? V dv by ds. So why you are writing the same thing here? Just have patience. A, can I write dv square upon ds? Right, student? So what did sir do? This is after integration. So integration would give us what? Half 2v dv by ds. Right now, student? So the whole thing is this after integration. Yes, sir, we have understood thing. So it is nothing but half. So what should I write? Acceleration is nothing but half of slope of v square s graph. Okay, student. Also note. Oh sir, there are so many things to note. Acceleration, velocity into slope of Vs graph. How come, sir? How this is coming to be? Graph. How this is coming to be? Because this is this thing, na? A dv upon ds. Oh, sir, now understood. Slope of Vs graph. Yes, sir. So the thing. This is what? Positive, negative, or zero slope. Signify slope. Slope signify what? Signify positive, negative, or zero acceleration. Right, student? Yes, sir.